This is Trigonometry, Lesson 1.2. We will be studying the right triangle. So, the study of trigonometry is going to show us, how to use right triangles when we know either some angles or some sides. And then eventually, we'll be able to talk about any kind of triangle. So you can read through this little piece up here. And the word trigonometry means the study of triangles. It means the study or of angle and side measurement of triangles. So we're going to be very interested in triangles throughout the entire course. Now, last unit when we were studying the different points along a circle, we were interested in the unit circle, but it's really made up of infinitely many right triangles. So we're going to see that at some point, not today, but soon. Okay, so this says trigonometry is used for so many different things: navigation, surveying, building, engineering, even the study of DNA. We begin our study of trigonometry by defining the 6 trigonometric, space there, functions as they relate to right triangles. So let's get a visual of just what I'm talking about there. So the first objective that we have here in this rather long lesson is to use right triangles to evaluate trigonometric functions. Now, there are 6 trigonometric functions, and they all have a very special name and abbreviation. And these words, this study of trig is 2,000 years old. So these words come from mostly Greek, but all of the years and years of math that's gone on with trigonometry, we've kept these words, these important words. And so sine is the first trig function we're going to talk about. Sine, S-I-N-E. Now the abbreviation, we abbreviate it S-I-N, and we do not say sin, we say sine. Okay. Now its cousin, its co-function is called cosine. Cosine. And we abbreviate cosine COS. And then there's tangent. Tangent's also a very important one. It's a combination of sine and cosine. We're going to see that in a little bit. And its abbreviation is TAN. Now there's something called cosecant. Cosecant. Its abbreviation is CSC. And then secant, usually we say secant before we say cosecant. Secant is SEC. That's its abbreviation. And cotangent is COT. So we don't say cot. The only one we do say is tan. I'll say tan sometimes instead of tangent. But, if you see SIN, you say sine. Because these are just abbreviations of these 6 trig functions. Now, these words have definitions, and we're going to have to memorize those definitions. It's very important to memorize them. And there's a couple of different ways to do that. Now, today, we're going to make it in relationship to a right triangle. So here's a picture of a right triangle, triangle ABC. Notice that we've got angle A with a capital A. Across from angle A is side A. We have angle B up here, and across from angle B is side B, lowercase b. And we have angle C, which is the right angle. And across from the right angle is always the hypotenuse of the right triangle, and that's called side C. So notice that the angle names, the angles are capital letters. So we have triangle ABC, and the angles are capitals. And then the sides Well, we have side AB, BC, AC. These are segments, AB, BC, CA, or AC. So it's important now to locate or talk about one angle of this triangle. So notice that this angle right here has been called angle theta, the Greek letter theta. So we're going to talk about this angle theta. And from angle theta, the side across from that angle is called the opposite side. Now on your notes, that word did not print. It must have gotten off of the margin there. So you'll need to write in the word opposite. On my picture, that's a green side. Yours it may not show up that way. The hypotenuse obviously is across from the right angle. Okay. It's always the longest side. And then this other side that we haven't named yet is called the adjacent side. It is adjacent or next to the angle that we're using, angle theta. So adjacent means next to. So it's sharing the side with angle theta and the hypotenuse. Okay, so now if we know, this side is opposite, this is adjacent, this is hypotenuse. By definition, sine of angle theta. So, here we talked about, there was a trig word called sine. This is a way we make the notation. S-I-N of the angle, whatever angle we want to talk about. We could have said angle B, but they want us to look at this angle theta. Sine of angle theta, by definition, is the length of the opposite side divided by the length of the hypotenuse. We call it opposite over hypotenuse. So sine of this angle is the opposite side over the hypotenuse. Whatever the length of BC is over the length of BA. Okay? So on my little triangle here, that side is called, that opposite side is called A. Sine is opposite over, this is side C. Okay? So I'm not going to memorize that as A over C. I'm going to memorize it as opposite over hypotenuse. Okay? Now cosine, let's go down this way. Cosine of the angle, by definition, and so this is something we just memorized, is the length of the adjacent side over the hypotenuse. So the adjacent over the hypotenuse. From angle theta, the adjacent is this side B over the hypotenuse C. Okay? And then tangent of theta is the length of the adjacent side divided by, we've got a mistake here. The length of the opposite side over the adjacent side. I didn't notice that there was a typo. Opposite over, and here it's right, opposite over adjacent. Please fix that in your notes. I'll go and fix it in the notes too. Make a note to myself to do that. Okay, so tangent is called opposite over adjacent. So from angle theta, tan of angle theta is the opposite side A over the adjacent side B. Okay? So we could have numbers here. We could know that this length was 5 and this length was 12 or something like that. And we could plug those numbers in. And that would help us to find the measure of the angle. Okay? Now over here, these functions are the reciprocals of the ones we just learned. So by definition of sine is opposite over hypotenuse. Cosecant, this one, cosecant, is its reciprocal. Notice it's the hypotenuse over the opposite. So all that happened here, opposite over hypotenuse became hypotenuse over opposite. So in this picture, that would be side C over A. Notice that these things are just reciprocals of each other. Okay, cosine's reciprocal is secant. Cosine was adjacent over hypotenuse. Secant is hypotenuse over adjacent. So that would be from theta's hypotenuse over adjacent, C over B. And these things are reciprocals. And then lastly, tangent's reciprocal is cotangent. So here we have tangent was opposite over adjacent, so cotangent is adjacent over opposite. Adjacent is B, opposite is A. B over A These are just reciprocals. Okay, so we need to memorize. We need to commit these things to memorization, and I have them written out. I wrote all of those rules here at the top of the next page of the notes. It says, in general, the trig functions of theta, which remember is an angle in a triangle, depends on the size of angle theta and not on the size of the triangle. Okay, so short version, sine of angle theta will be opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then the other three are just their reciprocals. If you know these three right here, if you memorize these three, and then you memorize which ones are the reciprocals, then you don't need to memorize the bottom three. Okay? So, an acronym to help you remember this. Sine is opposite over hypotenuse. See, S-O-H. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay, so some people, I mean, you probably learned this like, in high school math. Sometimes we call this SOHCAHTOA. SOHCAHTOA. If you can spell it, it's a little acronym to help you remember the formula. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. TOA, tangent is opposite over adjacent. SOHCAHTOA. So, maybe you write that up at the top of your page so it just gives you a way to remember the combinations for the trig functions. Some of my past students have said they remember it with some old hippie caught another hippie tripping on acid. Isn't that lovely? I bet we can come up with a better one than that. But what you got to do to memorize these things, right? So, SOHCAHTOA, we're going to use it a lot, all semester long. And it only deals with right triangles. You have to have a right triangle for SOHCAHTOA to work, okay? And today, we only have right triangles. Now, I need you to go back to geometry and remember some other things we know about right triangles, like Pythagorean theorem. Do you remember a squared plus b squared equals c squared? Now, it's important that c is the hypotenuse of the triangle. Pythagoras said that the sum of the squares of the legs of a right triangle is always equal to the hypotenuse squared. That was his formula. And there's lots of proofs of this wonderful formula out there. If you are interested, go look at some of them. There's geometric proofs, there's algebraic proofs. Very interesting. But I think this is probably something you remember. This is another thing we want to commit to memory. These are all memory things, okay? So, locate your hypotenuse. It goes on the one side of the equation by itself. And then the two legs make up the right angle. Okay? So this says find the value of the 6 trig functions in this figure. Okay, so notice that they've labeled the angle theta. That means that Greek letter means this is the angle we're talking about right here, not this one up here. I mean, because they could have picked that one. So we want to know what sine of angle theta is. Well, if this is your angle, then remember that sine is opposite side over hypotenuse. Opposite side is 3 over hypotenuse. We don't know what the length of the hypotenuse is. Okay, so we're going to use Pythagorean theorem to find it. You might already recognize that this is a 3, 4, 5 Pythagorean triple. This length is 3, this length is 4, and so this length has to be 5. Now, I only know that because I know Pythagorean theorem. Legs squared plus legs squared equals hypotenuse squared. Let me prove it to you. 3 squared is 9. 4 squared is 16. Now we do not take the square root of both sides yet. We've got to add the two numbers together on the left and get 25 equals c squared. And now we square root both sides. And so in algebra we find out that c is plus or minus 5. When we square root both sides, you get 2 answers. But this is a distance. We're only going to use the positive length. So we know that side C is 5. So now we know the three sides of the right triangle because of Pythagorean theorem. So let's go back to our sine value. Sine is opposite over hypotenuse. Sine is 3 over 5. That's our answer for sine of theta. Okay, what about cosine of theta? Well, cosine of theta is adjacent over hypotenuse. Cosine of theta is adjacent over hypotenuse, 4 over 5. 4/5. And then tangent of theta is opposite over adjacent, TOA. So here's theta, opposite over adjacent, 3 over 4. Okay, those are the first three trig values. Now, to their right, I'm going to write their reciprocals. So notice that sine and cosecant, CSC, are reciprocals. So I'm just going to flip over sine. No need to go do the opposite and hypotenuse stuff. Cosine's reciprocal is secant, SEC. And so I'm going to just flip over 4/5 and make it 5/4. And then tangent's reciprocal is cotangent. And I'll do the reciprocal of 3/4, which will be 4/3. And there's my 6 trig functions. And we just leave them in fractions. You don't want to go to your calculator for this yet. There will be a time and a place for that. Okay, let's, well, I didn't notice that I was supposed to write my answers down here. So sine of theta is 3/5. Cosine of theta is 4/5. Tangent of theta is 3/4. This one's moving horizontally. And then under it is its reciprocal. Cosecant is 5/3. Secant is 5/4. And cotangent is 4/3. Now, until you memorize, your very important definitions of what sine, cosine, tangent are, this will be very difficult. But once you know what the relationships are, then you figure out what each side equals. It's a very simple process. Let's do one more as an example. And I would recommend, now that you've seen one done here, that you would pause the video, work this example, and then turn the video back on and check your answers. Okay? So you pause, and I'm going to meet you back here in just a second. In this triangle ABC, we are talking about here angle theta. So we're looking at this angle. So over here is the opposite side. This hypotenuse is across from the right angle. And that leaves this side being next to theta being the adjacent side. Okay? The opposite side is 1. The hypotenuse is 3. And we don't know B. We don't know the adjacent side. So let's go do Pythagorean theorem. A squared plus B squared equals C squared. Now, they have labeled the legs appropriately, A and B. They do not have to do that. Okay? So you're not going to always have a triangle labeled A, B, C. So you just have to look and say, oh, the two legs make up the right angle. So I have 1 squared plus, I don't know the other side squared, equals the hypotenuse across from the right angle, 3 squared. 1 squared is 1. Order of operations says we do our exponents first. 3 squared is 9. Subtract 1, B squared is 8. So B is going to equal plus or minus square root of 8. Well, B is this distance, the length of side AC. So we're going to use the square root of 8, positive. And let's rewrite that as 2 square roots of 2. Because if we factor 8, we get 4 times 2, which is 2 times 2 times 2. We have a pair of 2's. When we talk about a square root, the square root of 8 will be the same thing as the square root of 2. These 2's broke out in front, and that 2 gets left under the radical. So reducing radicals is going to be very important in this course. It's something that you're supposed to already know how to do. So if you don't, you want to go look at some YouTube videos about reducing radicals and practice that. I just factor tree, and if it's a square root, you bring out pairs and write that number in front, and then whatever's left over gets left under the radical. But that's something important that you're required to be able to do. Our calculator cannot do that for us. And square root 8 is considered not simplified. So now we know side B. Let's go find our 6 trig functions. Let's start with sine. Let's recall that sine is opposite over hypotenuse. There it is. So looking at my angle theta, the opposite side is 1 and the hypotenuse is 3. 1/3 is the answer there. Now cosecant will be very easy now that we know sine, because sine and cosecant are reciprocals. It's going to be 3 over 1, or just 3. Cosine, do you remember, is adjacent over hypotenuse. Cosine adjacent over hypotenuse. So we're going to do from angle theta adjacent over hypotenuse 2 square roots of 2 over 3. And then secant would be its reciprocal, 3 over 2 square roots of 2. Now that is not simplified. We do not want to leave radicals in the denominator. So let's come down here. And let's remember to rationalize a denominator, we're going to multiply the top and the bottom by that radical. And the reason that works, you see, when I multiply square root 2 times square root 2, I get square root 4, which is 2. When you multiply a radical times itself, it removes the radical. Now down here I have 2 times 2, so my denominator is 4. 2 times 2 is 4. And on my numerator, I just have 3 times the square root of 2. That's my simplified answer. 3 square roots of 2 over 4. No simplifying here because that 2 is under the radical. It cannot reduce with the 4. Okay, so this is going to force us to remember some algebra skills that maybe you haven't used in a little while. Let's go do tangent. Tangent is opposite over adjacent. So let's look at our picture. Tangent is opposite over adjacent, 1 over 2 square roots of 2. Now that's not simplified, right? So let's come down here and let's rationalize that. We're going to multiply the top and the bottom by the square root of 2. The numerator, 1 times square root 2, is just square root 2. The denominator, 2 times square root 2 times square root 2, is 2 times 2, or 4. So our simplified answer for tan theta is the square root of 2 over 4. And then cotangent will be its reciprocal. Now, let's don't do the reciprocal of that answer, because then we'll have to rationalize it again. Let's do the reciprocal of this when they're equivalent. And that would put 2 square roots of 2 over 1 as our answer. And so there we go, we're simplified. So our calculator does not help us in this type of a problem. There will be a use for our calculator here in just a few minutes. Okay, I'm going to pause this video. We'll call this part 1. It was the first 2 pages of our notes from lesson 1.2. And then we will pick up with part 2 in the next video.